Welcome to solverfy.
When we look at the idea of molar mass, or atoms per gram, there are different ways that we can consider this. Each of these images shows a different number of particles and different masses, and so the lower down on the scale, the more mass. And each circle represents number of particles. So we can compare molar mass of each sample in A, B, C, and D. And molar mass is the ratio of the mass, or grams, per mole. We can also look at the ratio of the atoms per gram. So for example, if we consider example A, you can see on the left, there are 5 circles, and we'll say each one of those is a mole of particles. And it has more mass. And on the right, there are 6 moles with less mass. So if we look at the ratio of mass to mole, we want to see, in order to have the larger molar mass, should be something that has a larger mass number, so greater mass, and a smaller number of moles, because that's what will give us the largest number here, a big number on top and a small number on bottom. So if we look at these two, we can see that the one that has greater mass and less moles is the sample on the left. So the left has a greater molar mass. If we look at atoms per gram, in order to have a larger ratio, we would want a large number on top and a small number on bottom. So we can also consider each of these circles, instead of each being a mole of a substance, to be a specific atom of a substance. So if we look for the one that has the greater number of atoms and the smaller mass, that's the one on the right. So the right has more atoms per gram. If we look for the one that has fewer atoms per gram, that would be the one, to get a smaller number here, would have a large number on top, a small number on top, and a larger number on bottom, which is our left. And finally, which one has more the ratio of atoms per mole? This is the same because Avogadro's number always tells us that 1 mole is equal to 6.02 times 10 to the 23rd particles. So both have equal ratios of atoms to moles. If we look at example B, we can see that on the left, there are more particles or more moles, but less mass. And on the right, there are less particles and more mass. So we can do the same analysis as above. The greater molar mass is the one that has the larger mass and less particles. So that's our right sample. The ratio of atoms to grams to have a larger value is more atoms and smaller mass, which is the left. On the right, we also see there are fewer atoms per gram. And again, they both have the same ratio of atoms to moles. If we look at our third example, C, you can see here that they both have the same number of particles, but the one on the right has less mass. So if we're looking for the one that has the greater molar mass, that means the more mass per moles, which is the right. More atoms per gram, again looking for a smaller mass with the same number of atoms, would be on the left. And so the right would also have fewer atoms per gram. And again, the question of what's the ratio of atoms to moles, they both have equal ratio of atoms to moles. The last example, D, has different numbers of particles but the same mass. You can see that on one side, on the left side, there are fewer particles than on the right side. So if we consider our molar mass, if they have the same mass and mass divided by moles, we want the one with fewer atoms. So the left has the greater molar mass. Considering the ratio between atoms and grams, since they have the same mass, the more atoms, the greater that ratio. So the right side has more atoms per gram. The left side has fewer atoms. And finally, the ratio between moles and atoms is the same.